welcome back to my channel. I am back with another tutorial. This series and today's video is going to be on polynomials. This will probably be a 3 or 4 part series, but in this video we are going to be learning how to classify polynomials, how to multiply and divide polynomials, and how to apply them to word problems. So let's just get started. Okay, so firstly, what exactly is a polynomial? We can just describe it as an algebraic expression, but it's an expression where any exponent on a variable must be a whole number. So let's just go through 5 different examples and classify them as either being polynomials or not polynomials. So the first one, 3x squared plus 2x plus 1. The exponent on a variable is a whole number. X is the variable and the squared is the exponent, and it is a whole number. So this is a polynomial. The second one, negative 2x squared y squared z. Same thing here. It's negative 2x squared, but the exponent on the x is still a whole number, and the exponent on the y is also a whole number, so this is also a polynomial. Now the third example, x squared plus 2x plus 1 over x minus 9 is actually not a polynomial because, as we can see, in the denominator we have x minus 9, and on the variable x there's actually a 1 exponent. But in this case, since it's the denominator, that 1 is actually a negative 1, and that is not a whole number. So this is not a polynomial. The fourth example, negative x squared over 3 minus 9, that is a polynomial because the negative x is in the numerator and the squared is a positive 2, which is a whole number. So this is a polynomial. And now for our last example, I want you to guess whether it is a polynomial or not and why. But we have x to the power of negative 2 minus 12x plus x to the power of negative 1. So we actually have 2 negative exponents in this expression. So this is not a polynomial. Now we are going to practice multiplying polynomials. Okay, and this is basically just algebra, honestly. But it does get a little bit more complex as we go on. So let's just get started with the first example. We have 3xy times 7x squared y. So we multiply 3 times 7 is 21. And then x times x squared, you add the exponents when you multiply variables of the same base. So x times x squared becomes x cubed, and then we have y times y, which is y squared. Now for the second question, we have 8x times 3 over 2x minus 2. Here's where we apply distributive property, where we multiply what's outside of the brackets with each term inside the brackets. We have 8x times 3 over 2x, so 8x times 3x is 24x over 2. And then we have 8x times negative 2, which is negative 16x, sorry, this is 24x squared, minus 16x. And then we can simplify this first term, 24x squared over 2. This, we can divide 24 by 2 and get 12x squared minus 16x. Alright, so it's very important for you to be familiar on how to multiply these polynomials because, again, like I said, it's just going to get more complex as we move on. Here we have 3x squared plus 2x plus 1. This whole thing multiplied with x squared minus 7x plus 2. So we have to apply distributive property to every single term. So I'm going to go through this step by step. We multiply this first term with everything in the second set of brackets. That's how distributive property works. Okay, so 3x squared times x squared will just give us 3x to the power 4. Then we have 3x squared times negative 7x, so 3 times negative 7 is negative 21, and then x squared times x is x cubed, and then we have 3x squared times 2, which is just 6x squared. Alright, now we move on to the second term in the first set of brackets to multiply with everything in the second set of brackets. Alright, So we have 2x times x squared, so that just gives us 2x cubed. Then we have 2x times negative 7x, so that gives us negative 14x squared. And then we have 2x times 2, which is just 4x. And now lastly, we multiply this last term, which is 1, with everything in the second set of brackets. So 1 times x squared is just x squared. 1 times negative 7x is just negative 7x. And then 1 times 2 is just 2. Alright, and now we just are going to collect the like terms to simplify. So there's only one term that has the exponent 4, so we leave that as it is, 3x to the power 4. But we have two terms that are x cubed. So we have negative 21x cubed plus 2x cubed, so that gives us negative 19x cubed, right? And then we have 6x squared, negative 14x squared, and positive 1x squared. So 6x squared minus 14x squared is negative 8x squared, and then plus x squared is negative 7x squared. And we have 4x and 7x. Both of these have only the exponent of 1 on the x, so 4x minus 7x is negative 3x. And then we just have a positive 2 at the end. Alright, so this expression fully simplified becomes 3x to the power 4 minus 19x cubed minus 7x squared minus 3x plus 2. Now we're going to learn how to divide polynomials. We have 34x to the power of 4y over 17xy cubed. We know that 34 divided by 17 is just 2, right? Because 2 times 17 is 34, so we have 2. Then we have x to the power of 4 divided by x, and hopefully you know this, but if you didn't, when you divide variables that are the same base, their exponents subtract. So here we have x to the power of 4 and then x to the power of the 1, which is invisible. So 4 minus 1 is 3, so that gives us x cubed. The y in the numerator has, again, an invisible 1 as the exponent and 3 at the bottom, so y 1 minus 3, so we have negative 2. Alright, and if we wanted to write this in positive exponent form, it would be 2x cubed over y squared, or 2x cubed times 1 over y squared. Would be the same thing. Alright, and now the second example, we have 20a cubed minus 4a divided by 2a. Both of the terms in the numerator have a, so it can easily be divided by the denominator, right? So we have 20a cubed divided by 2a. That will give us 10a squared, right? Because 20 divided by 2 and then a cubed divided by a will be 3 minus 1, and that will give us 2. And then we have negative 4a divided by 2a, which will just give us negative 2. Because this is a 1 and this has a 1, and 1 minus 1 is 0. Now the next concept that we are going to go over is multiplying using the area model. Alright, and this is just basically a way to multiply and divide graphically. You might have learned this using cubes, like big cubes for x squared, long cubes for x, and then these tiny squares for just ones. But we are going to be doing something very similar, but just without drawing all the cubes, because that gets a little bit tedious. So just to explain what the area model actually is and how you use it, we're going to just do it with a 2-digit number instead of with variables. So we have 13 times 24. So basically how this works is you want to break it down into two terms that will add to give you 13. So we can use 10 and 3. Alright, and then we're just going to draw a little dotted line between these two terms, because 10 plus 3 is 13, right? So that's why we chose those numbers. And then we do the same for 24. We can just go with 20 and 4, because 20 plus 4 gives us 24. Alright, and then we just draw another dotted line through here. And now we just multiply. So we have 10 times 20, which is 200, right? And then we have 20 times 3, which is 60. And then we do the same for the bottom two squares. We have 4 times 10, which is 40, and then we have 4 times 3, which is 12, right? And then we take all these numbers and we add them together. We have 200 plus 60, which gives us 260, plus 40, which gives us 300, plus 12, which gives us 312. And if you calculate 13 times 24, it will give you 312. All right, now let's do another example with variables this time. X plus 4 times x plus 7. So this time, instead of using two different numbers that will add up to x plus 4, we actually already have them. We have x and 4, because x plus 4 is going to give us x plus 4. And then we have x plus 7. All right, and then we do the same thing. We just multiplied them. So x times x is x squared, and x times 4 is 4x. Then we have 7 times x, which is 7x, and then we have 7 times 4, which is 28. And then we do the same thing. We just add them all together. We have x squared plus 4x plus 7x plus 28. And then you check to see if there are any like terms that you can collect, and there are 4x and 7x. Then your final answer will be x squared plus 11x plus 28. Alright, now for the last section of this video, we are going to be applying what we learned to some basic word problems. We have a rectangle here, and some of it is shaded, and there's a portion that's unshaded. And we have to find a simplified expression for the shaded area. There are a few different ways to do this, but the way that I'm going to go about it is finding the area for the entire rectangle and then just subtracting the unshaded part from that rectangle to find the area of the shaded rectangle, okay? So it's important to know your formulas. So for rectangle, the formula for finding the area is just length times width, right? And we know that the length is 5x plus 3, but we need to find the width. And they gave us two portions here, right? They give us 6x plus 8 and x plus 2. So we are going to add them to find this total width, okay? So we have 6x plus 8 plus x plus 2. All right, so we're just adding, so we're just going to collect like terms, right? So we have 6x and x, so that will give us 7x, and then we have 8 plus 2, which will give us 10. So 7x plus 10 is our width, right? So let's just put that into our formula to find the area of the entire rectangle. So the length is 5x plus 3, and the width 7x plus 10. And here's where we have to apply distributive property and multiply all these terms. So first we're going to do 5x times 7x, 35x squared, and then we have 5x times 10, which is just 50x. Then we have 3 times 7x, which is 21x, and then we have 3 times 10, which is 30. And then again, we're going to collect our like terms, 35x squared, and then 50x plus 21x, 71x, and then plus 30. So this is our area for the whole rectangle. But we're not done. We only have to find an expression for the shaded area. So now that we know the area for the entire rectangle, we're just going to subtract this unshaded part. So let's find the area for the unshaded part of the rectangle. So we have, again, length times width. So 3x for our length or our width, whichever. And then we have x plus 2, as we can see right here. Okay, so then we just do distributive property again. We have 3x times x, which is 3x squared, and then we have 3x times 2, which is 6x. Alright, so that's for the unshaded part. Now to find the expression for the shaded part, we just subtract 35x squared plus 71x plus 30 minus 3x squared plus 6x. Alright, we're just subtracting, so again we just collect like terms. So we have 35x squared and negative 3x squared, right? Because that negative sign multiplies with what is in here and also what is the two terms in there, right? So 35x squared minus 3x squared will give us 32x squared, and then we have 71x minus 6x, 65x, and then we only have one constant term, so that stays the way it is. And that is our final answer. Alright, we have to find an expression for the area of the shaded region. Okay, so we have basically a square, and then we have a circle in the middle. Now, since we're trying to find the area of the shaded region, what we are going to do is find the area of the square, and we're going to subtract the area of the circle. Alright, so again, we need to know our formulas. So to find the area of a square, we know that it's just s squared. And then for a circle, if you didn't know, it's pi r squared. So we know that the side of the square is 4x plus 8. We subtract pi, and we know the radius here is 2x plus 4. So we just put that in place of the r, and we have to square that as well. If we expand it, this becomes 4x plus 8 times 4x plus 8, right? Because that's what squared means. And then same with here, we just have pi at the beginning. Then we have 2x plus 4 times 2x plus 4. Now we apply distributive property again. So we have 4x times 4x, which is 16x squared. And then we have 4x times 8, which is 32x. And then again, 8 times 4x is 32x. Then we have 8 times 8, which is 64. And then here we have pi again. Then we have 2x times 2x, which is just 4x squared. Here we have 2x times positive 4, which is 8x. And then again 4 times 2x, which is 8x. And then lastly we have 4 times 4, which is 16. Alright, and then we're going to collect like terms. We have 16x squared, 32 plus 32, 64x, and then we just have 64 at the end. And then here we have pi, and we have 4x squared, and then we collect 8x and 8x, which is just 16x, and then we have 16 at the end. So we have 16x squared plus 64x plus 64, and then that pi out here multiplies to every term inside. So then we have 4 pi x squared plus 16 pi x plus 16 pi. And then you can just put in the value of pi to calculate it, but if you're not allowed calculators, this will be your final answer. Alright everyone, so that is the end of our video. I hope you found this helpful, and I will see you in the next part in our polynomial series.